Hi everyone, welcome to my channel Big Bang Chemistry, a complete solution of the chemistry. In the series of molecular symmetry, today we are going to discuss the presence of proper axis of rotation in tetrahedral molecule or AB4L0 type of molecule. We know that tetrahedral molecule having the 109 degree 28 minutes, right? But when you will come to the symmetry, right? So it is very difficult to assume all the proper axis of rotation which is present in a perfect tetrahedral molecule. So basic concept is required that how we represent a tetrahedral molecule in molecular symmetry. So we represent a tetrahedral molecule in molecular symmetry in a cube, right? In this cube, this is your central atom and we place the word B atom at alternate corner of a cube. This is the representation of a tetrahedral molecule. So now we are going to understand the presence of three C2 proper axis of rotation in perfect tetrahedral molecule. We already understood that in a perfect tetrahedral molecule 4C3 proper axis of rotation, and how we will show the operation we already did. Now we are going to check the presence of 3 C2 proper axis of rotation. When you will observe this cube, right, then you will find there are 3 C2 proper axis of rotations are present. See that. So when you observe this cube very closely, then you will find in this cube there are 3 C2 proper axis of rotations are there, right? This is your first C2, right? So this C2 is what? Passing through A atom, right? And two opposite face also. Two opposite face of cube, right? Correct. Now second C2 is this one, which is again passing through A and two opposite face of a cube, right? Now third C2 is this one, right? So now we can easily visualize the presence of 3 C2 proper axis of rotation in AB4 tetrahedral molecule. So now how to perform this C2 operation? Now check the operation of this C2 operation in AB4 type of molecule. So before performing operation, just do one thing, draw one line, join this 2B atom with the help of one line. So reason is that when you will do it, then your operation will be very easy. So now we are going to perform this C2 operation about a C2 axis which is passing through A and two opposite face about this C2 axis. So now rotate this molecule at 180 degree. C2 means what? Rotation by 180 degree. So once you will rotate this molecule by 180 degree, so before rotation just mark this molecule B1, sorry, this B atom B1, B2, B3 and B4. So this is what B1, B2, B3, B4. Then what will happen? Again there is an interchange of position. B1 will interchange its position with B2, B2 with B1, right? Same thing happen on this face also, B3 with B4 and B4 with B1. So what is the new position now? Here who will come? B1 will come, here B2 will come, here B4 will come, here B3 will come. So now structure number 2, this is structure number 1, and both are the what? Equivalent to each other, right? Equivalent geometry we are getting. That's why this is what? First C2 proper axis of rotation. Now check the second one. So again before performing this second one, right? So we are going to perform this second operation about this axis, about this C2, right? Correct. So before performing this operation, just join this B atom in this way, right? So about this axis, we are going to perform the C2 operation, right? So what will happen? Again mark it, this one B1, this is B2, this is B3, this is what B4. So now when you rotate this molecule about this C2 axis in this direction, be careful with the direction. then first of all what will happen, this B2 will change its position with B4 and B4 with B2, right? On back surface what will happen, check here, this B1 will interchange its position with this B3 and B3 will interchange its position with B1. So now do all the interchanges, right? So first check the front face. So here B4 will come, here B2 will come, right? And the back face, who will come here, B1 will come, here B3 will come, right? So again in this structure, first is equivalent to the what, second one. That's why this rotation by 180 degree will give you what, one proper axis of rotation, which is what, C2. So second C2 proper axis of rotation is done. Now check the third one. So now we are going to perform this C2 operation about this C2 axis. So again mark it B1, B2, B3, B4. So now we are going to perform this operation. So in this operation what will happen, these two surface B atom will interchange its position, right? So perform the operation now. So when we rotate this molecule in this direction, be careful with the direction. So what will happen now, B4 will interchange its position with B1, B1 will interchange its position with B4, and here what will happen, this B3 will interchange its position with B2 and B2 will interchange its position with this B3. Here what will happen, this B3 will interchange its position with B2 and this B2 will interchange its position with this B3. So what is the new position of B1, B2 and B3, B4? So here who will come, B4 will come, here B1 will come, right? Here B3 will come, here B2 will come. So again structure number 1, structure number 2, these two structures are equivalent to each other. That's why this rotation by 180 degree is going to produce one proper axis of rotation, which is C2. So now it is clear that in tetrahedral molecule total number of C2 proper axis of rotation present 3 C2. There are 3 C2 and 4 C3 are present in tetrahedral molecule. So once you will repeat this video again and when you will perform the operation as we did, right, so you will understand more. So whenever anyone who is watching this video, please repeat this video again, do the operation, easily you'll understand that how to show the C3 and C2 operation on paper, no need of any model. So I hope that everyone is understanding the presence of C3 and C2 proper axis of rotation in tetrahedral molecule. Please like, share and subscribe my channel and comment in the comment section